Hello again, everyone. I'm Plastics News Conference Director Joe Pryweller. Welcome to this special live stream event on the recycling and filtering of post-consumer and post-industrial plastics. This discussion is presented by FIMIC and hosted by Plastics News. We are excited to bring you this discussion in live video and allow you to interact in real time. Our presenter today is Ludovic Pitrois, North America Sales Manager at FIMIC. Ludovic will be sharing FIMIC's technology and will explore the most suitable approach to recycle and filter highly polluted plastic material. Ludovic will answer your questions after the presentation. To submit a question, email pnevents@crane.com, or if you're watching along via Plastics News, LinkedIn, Facebook, or YouTube sites, submit your questions through those platforms. Let me now turn the conversation over to Ludovic Pitrois of FIMIC. Ludovic, the floor is yours.
Thank you, Joe. Good morning and welcome, everyone. I want to thank you, all of you, and especially those from the West Coast who got up early in order to connect with us today. And a special thanks to Plastic News for their support and the organization of this live stream, recycling and filtering of post-consumer and post-industrial plastics. During the course of this presentation, you will be able to ask questions in the webinar chat, and we will gladly answer them all as they come in or at the end of the presentation. We at FIMIC are very focused on the circular economy, and we see an opportunity to share our experience and knowledge, especially in the process of filtration for post-consumer plastics. We are always available to provide our help and sustainable development advice to any company that currently dedicates or wants to start in the recycling of plastic, mainly from the origin of post-consumer and post-industrial, since it is the way forward that in the near future, the sustainable development of the plastic industry can be consolidated. FIMIC started in 1963 manufacturing custom guillotines for cutting large parts such as plastic, paper, rubber rolls, and bales. In 1996, the company started in the plastic filtration process, managing to position in few years our filter model RAS, as currently we have more than 320 melt filters installed all around the world. With materials, it is as ambitious as it is essential today to make your pelletizing line more versatile and productive while improving the quality of your product and participating in new markets that we previously could not cover with conventional filters. This image is an example of the contamination generated by plastic waste. Much has been said of recommendation for the good handling of the different types of plastics, and thus facilitate the recycling process in their reuse. But in reality, plastic waste continues to arrive at the recycling plants with a high percentage of contaminants that make it necessary to add extra processes such as separation, sorting, washing, and still reaches the pelletizing line with a high percentage of contaminants. So how can we improve what is already recycled and what could be recycled? Today, what are the materials that we mainly see as recycled in North America? PET, PP, PE, LDPE, HDPE. But what are other materials that could be recycled? PS, EPS, PVC, WEEE, ABS, PUM, and many more. Examples of plastic that are separated for recycling include those in these images: post-consumer PP, raffia, big bags, and linear low-density polyurethane, LLDPE packaging film, or low density of post-industrial origin, although the latter do not come from garbage. Either way, they contain some contaminants such as label, ink, paper, and more. Depending on the region, state, and even the country, the amount and type of contaminants may vary. If you want to consult any material, we are available in the chat room to respond to each of them. In the first two images, we see regrinds, either unwashed or washed. In this case, it is HDPE, mainly milk jugs or cleaning product bottles. Once pelletized, these plastics are reused in new products such as cleaning product bottles, automotive oil containers, pipe pallets. Bottle caps, for example, which are usually made of PP, are reused to produce new caps, containers of all kinds, car accumulators, and more. The other image corresponds to expanded polystyrene in compacted blocks to lower transfer cost and comes mainly from fish boxes, construction material, or packaging in general. It can be reused to produce pots, residential or industrial thermal insulation, office accessories, and more. This type of material is very special, and many recyclers are expressing interest in recycling it today. So, how are the materials described in this picture processed? Once separated, these materials go into the pelletizing process that starts with feeding the extruder, designed according to the type and shape of the plastic. It can also include a cutting process and agglomerate in case of very light plastics. The design of the screw and barrel can also change according to the type of material and its contaminants. Hence, it can include one or more degassing zones depending on the ink content, or even in tandem or cascade system using a second extruder and its filtering system, including, of course, a pelletizer at the end of the line. Today, the filtering system has become an essential part of the pelletizing line, and to prevent it from becoming the bottleneck of the line, we must select the ideal filter for your processes. This being said, though, when we process highly contaminated plastic, we need an automatic filter, a self-cleaning to avoid constant screen changes. On average, with our self-cleaning system, you change screen once a week, increasing productivity in your pelletizing line and processing washed or unwashed plastics, which facilitates the purchase of material that you previously could not process or with more contaminants at a lower cost. I have seen cases, many cases, where maize screen are changed every 3 to 5 minutes with traditional filters, causing frequent machine downtimes, significantly reducing line productivity, generating more input and labor cost by requiring a fixed operator just to change the meshes, screens. Nevertheless, I really want to clarify that all filtering systems are efficient if used for the process that were designed for. Hence, the importance of selecting the right filter for your process, which will suit your actual production capacity and material type. So, how do we choose a filter? A filter must be chosen based on my needs, your needs. Ability to process any type of plastic waste. Ability to resist and eliminate aggressive contaminants such as metals. Ability to control the discharge rate and therefore reduce melt losses. Ability to choose the right screen according to the final product with no productivity reduction. Ability to adapt the filter to any extruder, new or existing. Ability to increase pelletizing lines productivity. These are different forms and types of plastic: post-industrial and post-consumer, washed and unwashed, like different varieties of PE, PP, ABS, PS, and more. Just imagine the different materials you might be able to process with the right appropriate filter, which today you probably cannot process and have some issues doing it. Here, we see different discharge of contaminants depending on the type of contamination: paper, wood, organic, metal, unmelt plastics. In the case of recycling, you will not always know the type of contaminants that can be found in the material you purchased. Therefore, a suitable and flexible extrusion line is required, as well as a versatile filter with economical spare parts consumption and spare parts price. Then, going into more details of the example before us, we will observe images of the different stages of plastic during its recycling process. First, the grinded PE as it enters the extruder. In the center, we see the discharge after the self-cleaning action of the filter with contamination such as label, aluminum, wood, and metal. On the right, we see the plastic outlet already in pellet forms. In this example of unwashed polyethylene film from the packaging, we use a laser quality screen with perforation of 200 micron, an equivalent of 75 mesh in woven meshes. These pellets are reused among others to make blown film of 20 micron thick, such as garbage bag. The average of our discharge consists of 99% contaminants and only 1% useful plastic. So our discharge is among the lowest between the different filtration systems. If you also process this type of material and have questions about how to implement this extrusion process, please feel free to either communicate it now, by phone or email later on. Let us look at some other examples of materials to create more interaction and exchange of ideas in new recycling application in North America. Here, we see post-industrial polyethylene with the same screen and contaminants. In addition, we can clearly see paper and adhesive tapes. The final color of the pellet changes according to the type of plastic and its contaminants, but also affects the color when the temperature and pressure are higher than normal in the filter area. Our filter has the largest filtering area or surface on the market, with only one screen, allowing better temperature and pressure control in the filtering area, avoiding material, odor degradation, and color change. So we see post-industrial polyethylene and the same screen and contaminants. We continue with polyethylene, but a type of material that at the extrusion level is easier to process because it's heavier in density. However, at the filtration level, it is more complicated by its fluidity index, MFI, which is very often stiffer. We talk about high-density polyethylene, which can logically be of various types. Here, we see the washed post-consumer bottles. We reduce the perforation of the laser screen to 150 micron, equivalent to 100 mesh, to be able to remove label and aluminum efficiently, always maintaining a very low pressure level and then not allowing soft contamination such as elastomer or rubber to pass the filter screen because of high pressure. These pellets are reused in piping, new bottles for cleaning products, and very recently, thanks to technology in the market that make take the smell out of the pellets, also for cosmetics. Here, we see a mixture of high and low density PE filtering at 150 micron, laser screen, and a discharge of contaminant containing wood, paper, and unmelted plastic. Other example of circular economy and material that could be recycled. This image corresponds to the expanded post-consumer polystyrene filtered with a screen of 250 micron, equivalent to 60 mesh. This material is very special and difficult. Very often, it cannot be washed because of its very light and its electrostatic nature. Then, contamination level can be very important. A finer filtration can also be applied to produce micropellets in case of the application that requires it. Still, XPS, also called post-consumer or post-industrial unwashed installation expanded polystyrene. Our customers filter this material with a mechanical perforated screen, non-laser, so-called punched, from 400 to 500 micron, an equivalent to 30 to 40 mesh, to produce insulation panel again. Another advantage of our filter is that we can select between laser screen and punch screen to lower cost when we do not need fine filtration. Depending on the material, contamination, and final application, you can choose the necessary and appropriate filtration to have the necessary quality, and paying only what is necessary as spare part is concerned, and purging of the discharge material based on the contamination amount. Here, we see polypropylene from big bags fabric, raffia, packaging material from polypropylene woven tapes, with the use of a laser screen of 200 micron, equivalent to 70 mesh. Contamination of aluminum, wood, and PET fibers. Here it is possible to filter PET as its melting point is at approximately 260 degrees centigrade. Hence, the importance of good temperature control in the filtering area that is possible only if the pressure accepts at a low level. We have many customers asking us to recycle this type of material, but it will only be possible with a good filtration process, but also an excellent crushing and washing system. In Colombia and Kenya, we have customers who only recycle this type of material to reproduce PP tapes again, with a percentage of recycled material sometimes as high as 50 to 70%, and applied filtration of 120 micron, 120 mesh, or even 100 micron, 140 mesh. This image corresponds to the PS regrinds, treated on the 200 micron screen, with paper as the main contaminant. Once recycled, PS pellets can be reused for the manufacture of appliances, clothing hangers, and more. In recent years, PS and ABS from E-West, which were previously shipped to China, have become more important, while now they must be recycled locally. Today, we have many installations for this application with excellent results. Obviously, now it is worth mentioning some cases of less frequent materials in recycling, such as PVC or PVB, mostly used for application that requires strong binding. In both cases, though, we have also installed filters that successfully recycle those materials. In fact, I would like to proudly announce that FIMIC successfully installed in 2019 the first filter to treat PVC waste, both flexible and rigid. Since then, we have seen a lot of interest from recycled PVC companies for our FIMIC filter, as it is the only solution to filter this type of very sensitive material continuously and not manually. Our system will check the ease and speed with which the material flows within our filter, which present no dead spot nor any corner where the material can reside and therefore degrade, which we know in PVC is often a real issue. In the case of PET, the material is known to be very clean compared to post-consumer or post-industrial. So for PET, many customers use manual filters or backflush filters. Since we talk about percentage of contamination in part per million, so there should be no need for a self-cleaning automatic filter to process it. There are other alternatives. For this reason, we can say that in the case of post-consumer and post-industrial polyethylene, the return on investment of an automatic filter is much faster. In any case, as we like to give real answers, we're planning to start up the first FIMIC filter for PET recycling within a few months from now. Returning to the point of capabilities that our filter should have, We continue with the ability and flexibility to choose the type and size of screen according to the properties that your final product should have. It can be with laser drill screen for fine filtration with perforation in the range of 80 to 300 microns, or mechanically drilled screen for coarse filtration with drilling from 400 to 2000 microns. In this enlarged picture, you can see the difference between the screens drilled with laser technology and the woven meshes or even Dutch weave mesh type. Those three classified as 200 micron. We can definitely see on the left laser screen picture the precision, consistency, and uniformity of all its perforation. While on the woven meshes, we see the center picture, a substantial difference between the opening of the fabric and the lower variation, the right picture, but will definitely deform during the process, especially with high pressure, but of greater cost and certainly remains less uniform than the laser screen. In any case, we can choose between increasing the size of the perforation in our laser screen to get the same level of the previous filter with the woven mesh, or we can preserve its actual size, in this case of 200 micron, and achieve a significant increase in quality of the final product, thanks to the much more defined precision of the laser screen during filtration. Another point to evaluate is the high pressure of molten plastic when using woven meshes. The opening of the mesh will let more contaminants to pass through the fabric. And if you decide to clean a used woven mesh with open flame instead of replacing it, it will accentuate the opening between the fabric, will decrease the final quality of the material and reduce its sales value. However, with the use of the laser screen, you will obtain a better quality product and achieve greater use of your material. Customers who previously did not purchase your material will now be able to evaluate you as a reliable supplier of high-quality recycled plastic. Furthermore, because in the near future, all plastic companies will be required to integrate higher percentage of recycled material into their product and will definitely look for a constant quality supplier. I will be delighted to discuss all of the costs and gain details with you if you're interested. It is our commitment to help you evaluate how to lower production costs, improve quality, acquire cheaper material than other recyclers reject, and add more production to your extruder and a better efficient use of your operators. Now we can talk about flexibility again. In addition to be able to choose between various types of screens and different level of filtration, we also have the ability to choose between different production capacity, determined mainly by the filtration area or surface of your screen, which, as we see in the table, which goes from 120 square inch up to 588 square inch of filtration area. Advantages? Well, fast patches of molten mass, less residence time. This is only possible because we use a laser screen and it is 1 millimeter thick. So the resistance to the passage of the plastic is minimal. And of course, the structure of the filter's body, which is smoothly conveying the melt through. Extremely low operating cost. We only use 1 screen and 2 extremely economical blades. Lower operating pressure, possibility to work at low temperature, avoid polymer degradation. The largest filter surface in the single screen, just like I already mentioned. Fast screen change, between 20 to 30 minutes by only 1 operator. Less downtime, change on average every 5 to 7 days. No operator needed to continuously change screens, and improve the quality of the final product. So now I'm going to show you a little animation which explains the functionality of our filter. As you can see, the material comes from the extruder on the right hand side, and it enters on sideways on the filter and will fill up the chamber. It will only pass through the screen when the chamber is full. As you can see here, we have the scraper who actually will keep all the contaminants inside the chamber, and then we'll, I can do it, sorry. We will just purge, the bad contaminants out of the screen. As you can see, this is very simple screen with only, a few parts. Again, only one screen in all our filters. One scraper, two blades. So for your information, we can tailor our filter to any extruder, new, existing, or used. That allows us to replace our current filter to ours in just 4 hours of work, because the filter will be built specifically for your line with flanges and high specifically customers to your need. Using only one screen with 5 available diameters allow us to evaluate what is the ideal filter size for your line, considering material, fluidity, index, FI, filtration level, capacity of your extruder, and contamination. It naturally generates a great peace of mind for our customers that FIMIC includes with our filter the input flange to the extruder and output flange to the pelletizer, as well as the custom design of our electric circuit according to their requirements, including electrical safety connection with the extruder. Our operation software is really simple and intuitive, thus making it possible for every operator to use it. When we talk about the ability to increase the production of the pelletizing line, it is because a lot of pelletizing lines have their bottleneck precisely in the filter. Our self-cleaning automatic filter will help release the actual capacity of your pelletizing line, thanks to its extensive active filtration surface. Normally, our customers talk about 10 to 20% increase in throughput compared to the previous filter they had installed. Naturally, only if the extruder can produce it. It could be that your current extruder had been guaranteed for some capacity and cannot reach maximum productivity because it has the bottleneck in the filter. So please contact us to jointly evaluate if you can do anything to increase your production capacity. Next, I would like to share the experience of some of our customers in different recycling applications with a single wide range of extruder size and brands. Many extruder manufacturers recommend our filters as the best option in case of recycling of post-consumer plastic. And with them, obviously, we have a very strong collaboration. As with the rest of the manufacturers, professional respect has allowed us to always achieve success in the end because we all seek to the maximum possible results for our customer. Regardless of the extruder brand our customer chooses, we adapt our filters to the extrusion line they selected. For example, This image shows a Gamma Mechanica extruder in tandem or cascade configuration for degassing highly printed, wet, and contaminated film. They process unwashed low-density PE, commercial origin, at a capacity of 1,000 kilograms, equivalent to 2,200 pounds per hour, using a 500 millimeter diameter RAS-type filter. We start with cascade lines because normally many extruder brands for post-consumer prefer to use two-stage extruders. But obviously, most brands that do cascade also manufacture standard lines. Here, we have a Starlinger CVAC that processes unwashed low and high density PE from the post-consumer and post-commercial at the rate of 1,980 pounds per hour with a RAS filter 500. In this image, we see an NGR extruder processing unwashed PP raffia of post-industrial with a capacity of 880 pounds per hour by means of a RAS 325 filter. In this case of Pre-Alpina, extruder processes washed post-consumer LDPE at a rate of 2,640 pounds per hour with a RAS 600 filter. This is 600 millimeter diameter in screen. In the Technova extruder, unwashed PP flake is processed at a capacity of 3,300 pounds per hour with a RAS 500 filter. This capacity is achieved because of the customer use a filtration of 500 micron with perforated punch screen. In this David Standard extruder, they obtain 4,000 pounds per hour in unwashed low-density PE with a RAS 600 filter. Most of our installations in North America are on DS extruders. A Vicotech line processing unwashed low-density PE packaging film at a capacity of 1,320 pounds per hour with a RAS 400 filter. In this Ostun of Turkey, unwashed low-density PE is processed at a capacity of 1,870 pounds per hour through a RAS 500 filter. This Polystar extruder processes unwashed LDPE packaging film as well as PP raffia bags at a rate of 1,980 pounds per hour with a RAS 500 filter. In the case of with the Ye extruder, unwashed LDPE with a capacity of 1,100 pounds per hour with processed with a RAS 400 filter. In this twin screens cascade extruder, Coperion, we process unwashed XPS at a rate of 2,200 pounds per hour with a RAS 400 filter. Krasmafer Berchthof twin screws extruder to process washed HDPE at a capacity of 6,160 pounds per hour in RAS filter with a mesh 700 millimeter in diameter and filtration down to 150 micron. Pretty impressive. ICMA St. George twin screw for PP with capacity of 4,400 pounds per hour with RAS 700 filter and 200 micron screen. And finally, this is a Binova twin screw extruder for PP with capacity of 3,300 pounds per hour with a RAS 600 filter and 300 micron screen. Unfortunately, we could not show you all pictures of our successful installation due to the confidentiality with our customers. But as I mentioned earlier, we adapt our filters to all types of lines and brands. We want to share with you our experience in plastic filtration post-consumer, so we are at your disposal for any query of your process. As you probably already know, we want to reiterate that we have also pelletizing line in our plant in Italy for testing. Do not hesitate to contact me should you have any needs for a material trial. In this webinar live stream, I talk about our best-selling filter being the RAS type, but we also have other models for other specific applications. We have the RAS plus REF for application requiring back flushing system. We have the ERA. It's a double filtration within the same equipment for highly contaminated and very aggressive contamination. We have the GEM with the largest filtering area for very high throughputs. And last, we have the 10 for low contamination application with roll mesh. Finally, I have the great pleasure to show you the newest ship that FIMIC built this year to increase our production and productivity. By 2021, we need to grow along with the percentage of recycled plastic material worldwide. Finally, today, the world has understood the importance of plastic in our lives. But this being said, it is unequivocally necessary to recycle in order to prevent it from ending up in our trashes, landfills, and or in our oceans. We need to create a cleaner world for future generations. Last but not least, I am very proud to announce that FIMIC won this year, 2020, the award for the best continuous melt filtration technology. So thank you very much for your attention. And if you would have any questions, we'll be ready to answer them all. Thank you. Joe?
Great. Thanks, Ludovic, for a terrific presentation. We're now ready for questions. To submit a question, you can email pnevents@crane.com, or if you're watching along via Plastics News LinkedIn, Facebook, or YouTube sites, submit your questions through those platforms, and we'll get to all of them in the order that they are received. Before we get to questions, I want to introduce Erica Kanaya, FIMIC Sales Manager. Erica will assist Ludovic in answering audience questions. Let's move on to our first question to you, Ludovic and Erica. We'll talk a little about the setup of this somewhat and what's needed. First question, would FIMIC send technicians in order to take care of filter startup at the customer's plant?
Yes, we usually do. But in case where the health situation does not allow traveling, we do it in a remote mode with supports from Italy with a special application developed by FIMIC. In fact, in the course of this year, several startups have been done with this novel system, all with actually very good results.
Great. So you can do some of this virtually if necessary too, if you need to, with in today's environment. Does that work pretty successfully for you guys?
Definitely. Erica, maybe you would like to add anything?
As you probably know, plastic would be a little bit destroyed in the last few years from social media and from consumers, but we are working very hard to support recycling. And I think that it is very important also for all consumers to understand how the recycling works and how it is important to separate plastic from any other material. And obviously, what cannot be, our ends cannot done, our filter can do.
Excellent. Well, a similar question about the startup and the use of this. This concerns testing. Can I send my plastic material with special contamination possibilities for testing in your laboratory? What's the necessary quantity in order to run a test and to do this kind of thing?
Yes, of course. We only need the details of your material. So we need, of course, information coming from you as what do you want to test. If you want to test and send, the material, to Europe, we will need 1,000 kilograms, which is about, 2,200 pounds. We can test the material in our laboratory. The material must be grounded and washed in case of excess dirt, and in case of light material like film, it must be agglomerated or densified before shipping. But otherwise, we can do it directly in Italy, yes.
Excellent. Well, that's good. I imagine you get a variety of special cases and contaminations, and you can deal with all sorts of different things, right?
Definitely, yes. Maybe Erica could tell us, all the types of materials that we've been testing in Italy, but it's huge.
Personally, I follow many tests because it is since 8 years that we have our laboratory test in Italy, and every single customer can ship the material that wants to process. Obviously, nowadays we are working, thanks to the technology, we are working with videos, with all the technology that help us to do online, live. And we can take picture, we can share videos, we can do everything. We do a report to the customer, or you are personally invited to assist on any test. We process normally polypropylene, HDPE, LDPE, normally post-consumer, but obviously if you can work post-consumer, you can work as well post-industrial material. Our normal contamination that we can normally process is the paper, because we have many labels that has to be removed from packaging film, for example, or we can remove aluminum, we can remove cardboard or wood. So many contaminants. The filter is very important, that can remove unmelted also plastics. So in case also Ludovic shows PET that can separate from PP. So we are very open also on new challenge. So if you have a very particular material, we can test it, and we can, as a consultant, explain if it can be processed or not.
Are there materials that pose the biggest challenge as far as processing goes?
There are many now. The problem are the multi-layer. So this is the main material that everybody would like to separate different kind of material.
Sure.
But layers are so thin that is very difficult to separate. So this is the main challenge, I think, for 2021, and everybody are trying to find out new technology to process this kind of material.
How about contaminants, Erica? Are there certain contaminants that pose a more difficult issue with some of this, or what are you seeing lately, I guess, as far as having to filter different types of contaminants out of the material?
We have tested many occasions also the silicon as contamination can be a great challenge. And we have tested our ERA model that can filter twice in the same chamber, can filter twice the material. And in this case, we have removed 20% more the silicon, filtering twice. So we have 5 different kind of models depending on the material and the contamination. We are here to assist the customer to find out the right model for the process.
Excellent. Well, we have a question that came in via our YouTube site with this, and I'm going to paraphrase it somewhat. The question was, are there other plastic technologies that exist to work on contamination? And we'll start there anyway. And I'm curious too how popular the use of filtration is in the States or globally, I guess, anyway, with some of that.
Ludovic?
Well, for the plastic technology, are the plastic technology that currently, I don't quite understand the question. May you help me, Joe, on that one?
Yeah, that's why I tried to paraphrase a little bit, but is filtration, I guess a question I'll have for you, I'll change a little bit. Is filtration commonly used in the industry right now to filter out, to get rid of contaminants, or other technologies that are used for that kind of thing too?
Well, I think, we all know that there is 2 types of filtration right now. I mean, there is the mechanical, that's what we do in FIMIC. And then there is also the chemical. But, when you read all over what's happening all over the world, chemical could eventually, be a solution, but there is so much work to be done. And I don't think there is any proof right now that it can be done 100% as they say that it does work. Mechanical right now is probably the best technology that can be used to remove any type of contamination. Again, just like Erica was mentioning, silicone is probably one of the most difficult part of contamination, to be removed. But again, with our new filter era, this can be achieved. Again, are we going to achieve the 100% removal of silicone? I think it is really unrealistic, unfortunately, to remove 100%. Now, again, the customers were going to have to tell us what is acceptable or not, and this is why we can run tests and see the result from this test.
Excellent. Yeah, that's great. Go ahead, Erica.
Give also a numbers only to compare. To give an example, so only in Italy there are 150 companies that are processing recycling materials, so they can use the filter. Okay, so in worldwide there are so many companies that are recycling. So only to give a number to compare, only in Italy are 150. Okay, so I think that we have to improve, we have to grow up, obviously, into the recycling to avoid the pictures that Ludovic shows with all the plastic waste under the land. But we must have an idea exactly that the technology are growing, improving, and so in few years we can have more and more technology that will be discovered.
Great. Here's a more technical question. How do you remove aluminum foil in toothpaste?
Well, we at FIMIC, we manufacture special blades. And when you have some kind of aluminum contamination, we have to use these special blades. So this is why it is always very important every time when a potential customer would like to purchase a filter or has an idea of what they would like to process, they need really to tell us the maximum of information as the contamination. But again, these blades are made specifically to remove aluminum and also silicone. Erica, would you like to add anything else?
I think that you showed HDPE before. That is the common material. It's shampoo bottles, and the shampoo bottle has also the label of aluminum. It is the same concept. So the tube paste is made by so medium density polyethylene, and in the same way that we remove the label from the shampoo, we can also remove the aluminum foil on the paste.
Great. Another question, should switching between polystyrene, polypropylene, and polyethylene be minimized when you're extruding with this process to remove contaminants?
Erica, I'm going to let you answer this one.
Sorry, should switching between
different materials like polystyrene, polyethylene, and polypropylene be minimized?
We can switch from one to the other, no problem at all. So the time that is needed from the extruder to switch from one material to the other, it is the time that is needed for the filter.
Okay, great.
I read recently actually an article talking about these specific questions, because what customers ask us to do is, they tell us, okay, we're working on PP. So we would like, to remove, all the contaminants from PP, and they tell us exactly what they want to remove. There is now this new questions of, we want to generalize a filter. We want to be able to filter anything. So that's going to be another discussion actually, because we want to give you the best answer every time we sell you one filter. So we'll see what the future is going to be.
Excellent. We'll work on that. And the next question too is specifically about PVC. Can you expound a little bit on your technology for recycling PVC for rigid and flexible plastics? How's the screen stand up to the corrosive nature of PVC, and what's the life of the screen with this?
It is a very technical question, and,
yes.
and also very clever. I can say that we have a few filters that are processing PVC, flexible and rigid. The difference it is that with the rigid, you will have a lower output compared with the flexible. But thanks to the fact that our melt filter, it is the bigger for the surface that we have, this allows the filter to process also PVC, that is very tough, hard material. We are working with 150 micron, with 200 micron, so also very thin filtration. The difference between a PVC filter and the other filter is that it is threatened inside, so it is completely chromed inside, and this is permitting to avoid the corrosive nature of the PVC. Now this filter is still working since 2 years, and fortunately everything is fine. So I can admit that we tested successfully, and we don't have any problem with the nature of PVC.
Excellent. Questions. It's a bit of a takeoff on the one about plastics technologies, but the question is, should someone be cleaning the plastic before it is processed through extrusion?
Yes, probably they want to clarify the last question. It was technology that currently exists. Yes, there are, as Ludovic specified before, there is the sorting systems that permits to separate materials from one to the other, and this permits obviously to clean the plastic in this way. From the other side, there is the washing line. The washing line permits to wash exactly the plastic, to remove, for example, in case of agricultural film, we can remove the dust, or the recycling ward can remove the dust. And obviously, so this the technologies are existing and are permitting to work again, to process again the plastic in new products.
Great. Here's another question that came in through email. Can the filtering reduce the smells of recycled polyethylene?
As well, yes. So we have tested many times, and also our filter permits to reduce, obviously not 100%, because if not, we are speaking about virgin material. So we are speaking about recycling material, but we are reducing as well the smell, because we can work with the low temperature. So, and this is also the other parameter that is needed when we recycle material like post-consumer, thanks to the fact that we have the bigger surface.
Excellent. And again, send your questions into pnevents@crane.com, or if you're watching this via Facebook, LinkedIn, or YouTube, send your questions for those. We have time for some more here. Question for you: when the filter works in continuous scraping mode, is there more waste?
Actually, no, there is none. We have a PLC, and through the PLC, we can control the opening of the valves and how often the valve should open. So it should be exactly the same thing as continuous, or it will be on pressure mode. Erica, would you like to add anything?
Yes, take into consideration that continuous doesn't mean that we continuous discharging. Means that we continuous scraping. So this it is obviously it is the word can create a confusion, but we discharge only when it is necessary, because our scraper is hollow inside, so we can collect the contaminants and we can discharge only when it's needed.
Great. Can someone install a FIMIC filter before a strand pelletizer?
The automatic strand, yes.
Okay, great. And up to what percentage of contamination can the FIMIC filter work?
Well, right now, actually, we can work up to 15% of contamination. But it depends on the material of contamination type, and as in all cases, we like to first evaluate all the details of any application, of course.
Yeah, we cannot compare 15% of paper with 15% of metal or dust. So for this reason, it is very important to evaluate the type of contamination that the customer should remove.
Great. Let me ask you a little bit about your production site, Joachim. Where is it opening, and how will that affect your operations and anything else you're working on anyway?
We are working very fast because we are not traveling, so we are concentrating our efforts on the new facility. So we have always to take into the positive way what is happening. So we are working very hard to complete the new facility. I think that in February maximum 2021 we will be ready. And end of January we will have our new laser machine. So we will produce internally our spare parts, our screens. It is the 6th machine in the world, and this will permit us to be more competitive and fast than before. So we are trying to obviously improve our productivity and our service, because we think that the service for the customer assistant is always the best way to have a satisfied customer.
Terrific. So look for more news on that coming up by the first quarter of next year anyway. Terrific.
Yeah, sure.
A question that came in from email: what are the key indicators to know that a filter needs changing?
It is easy, in fact. So please, Ludovic.
I couldn't hear you. I'm sorry. Go ahead, Erica.
Oh, what are the key indicators that a filter needs changing?
So it is very easy because the pressure can help a lot. So when the pressure is increasing, compare on how the normal pressure, working pressure that the customer has, you can realize that the filters, the screen has to be changed. Normally, our customer do it very easy because they decided to do it every week. Okay, so if they are working 7 days, for example, they are normally replacing the screen on Friday, so they will have the new filter for the weekend, and they can work one week. This is the normal attitude that I have realized from our customers, but someone prefer also to change every 2 weeks. It depends on the contaminants they can find inside the material. We have also customers that they didn't replace the screens for 2 months, but obviously this is not our common customer, because if we work with post-consumer, they normally work 1 week.
But we also have in our system a diagram that can show on the screen of our controller. And it shows that the diagram, every time you will purge, and it will show, for example, the pressure level inside the filter. So if you do not change your settings and you get more and more purge of the system, you will realize, of course, that the screen needs to be replaced.
Terrific. We have time for one last question that came in. How do you know if a purge is filtering too much good resin?
We can adapt also the seconds. So we can adapt not only how much often the filter should discharge, but also for how many seconds. So this is very, very easy because our discharging valve is open, so you can see the discharge, and immediately you can, with the touch screen, you can adapt the seconds opening valve.
What I think is very important, Joe, is to make sure that the operator of the line or the screen understand what type of material they received. If is the material clean, has been washed or not washed. A lot of training will have to be done, or has to be done with our customers, to make sure that they understand, whatever they set on the machine, they set an opening of 4 seconds, 5 seconds, and then they're going to have actually the purge coming in every 45, 50, 100 seconds. They need to understand why is it so. So a lot of training will have to be done, and I see there is a big need into this area.
The advantage of the FIMIC filter is the flexibility. So this the filter can be adapted in any material, and so if the customer is working polypropylene now, but in 1 week we'll split to the HDPE, they can do it. So this is our main characteristic.
Excellent. Well, with that, we'll end it with that question. But I want to ask either Ludovic or Erica if you have any parting comments, final words you want to leave the audience with today.
Erica, I'm going to let you have the final words.
We must improve recycling. We must have good partner with our process. So we are here not only to sell a machine, we are here to help you to recycle and better.
Excellent. Well, with that, I want to thank Ludovic Pitrois and Erica Kanaya for a terrific job answering all your questions, and Ludovic for a great presentation too on this important topic. And I want to thank everybody for all the great questions that came in also and for listening to this today. And I also want to thank FIMIC for sponsoring today's live stream. If you want to follow up with Ludovic, his contact information and the company's contact information is on the screen, and he and Erica would definitely welcome your questions and comments and happy to discuss this further with you. We appreciate your attendance for this live stream presented by FIMIC and produced by Plastics News. If you want to revisit this chat, the entire event will be archived on the live stream webinar section of plasticsnews.com. I'm Joe Pryweller, and I want to thank you for joining us today for this live stream. We'll see you soon.